Ladies and wieners, we are going to be doing a walkthrough of the Pico CTF reverse engineering challenges WinAntiDbg 1, 2, and 3. It was live during the Pico 2024 competition rounds. At the moment, it is not currently live in the Pico gym. So you go to the Pico gym to reversing. Oh, actually, it is. Okay, it is live now. So yeah, you actually can try this. So let's just get started with the first one. The first challenge is for 200 points. It's called WinAntiDbg 0x100. It says, this challenge will introduce you to anti-debugging. Malware developers don't like it when you attempt to debug their executable files, because debugging these files reveals many of their secrets. That is why they include a lot of code logic, specifically designed to interfere with your debugging process. Now that you've understood the context, go ahead and debug this Windows executable. This challenge binary file is a Windows console application, and you can start with running it using CMD on Windows. The challenge can be downloaded here, unzip to archive with password picoctf. Alrighty, let's go ahead and download it. And let's extract it. Password picoctf. Awesome. So it says that it's a console application, so we can open this in terminal. Alright, let's just try running the code. And it says, welcome to the anti-debug challenge. To start the challenge, you will need to first launch this program using a debugger. Alright, so we are going to be using my trusty Binary Ninja. And let's open up. Boom. You can obviously use any disassembler or debugger that you like. Alrighty. So, looking at this program, it doesn't look like it's being obfuscated in any way. And already right off the bat, I can see a syscall calling is debugger present. So, let's go to the main function first. I always like to go to the main function and see what we're working with here. So, if we can find that at all over here. Main function, anyone? Let's look it up. Alright, well, we can't see any main function. So if I can't see the areas of the code for the main function, because it seems like perhaps some of these function names are actually obfuscated. I like to take it from top to bottom and the disassembler. So let's just scroll up to the top. Okay, this is just the PE file headers and stuff. Just pass through. So taking a quick look at this, there clearly is a point in this code. Okay, it's loading NTDLL, where it is detecting if we are using a debugger or not. So let's quickly run this with the debugger first to see what happens. You can already kind of see some of the code right here. To start the challenge, you have to blah blah blah. Here's your flag. Okay, so this looks like a very important function. This might even be the main function right here. Sub 401.580. Let's run it with the debugger real quick though. So let's see. What do we get? Okay, let's run. Alright, it says, welcome to AntiDbg Challenge Level 1. Why did the clever programmer become a gardener? Because they discovered their talent for growing a patch of roses. Oops, the debugger was detected. Try to bypass this check to get the flag. Okay. So we obviously can't run it without a debugger like this. We have to run in here and it says a patch of roses in quotes. And we can obviously assume that patch we will need to patch an assembly function instruction to bypass the check to get the flag. So let's go back to what we had earlier. Where was that code at? I want to say it was sub 480 or something. Pretty close to the top. Okay, here it is. Level 1, why the clever programmer? Alright. And you can see after it prints that string, it's doing if is debugger present is not equal to 0. Oops, the debugger was detected, which is what we got down here. If LP output string is not equal to 0. Good job, here's your flag, and it's going to print as the flag, which I assume is right here. Alright, so let's turn this into assembly and we can walk through these instructions. What we could easily do here though is just invert this instruction right here where it's checking for the syscall. It'll bypass that check and we can see if that works. So let's swap to this assembly. Okay, and you can see it looks a lot better in assembly. It's calling this syscall is debugger present. It's going to test and then jump to this address 0x7c161b if it is equal to 0, so that's positive. So let's invert this branch. Invert branch. Alright, and now that we've inverted that branch, we actually save this new patched binary. So let's actually save. And we'll call it 0x100 underscore patched. Save. Alright, and now let's open it in a debugger because it needs to be open in a debugger. And if we launch this file, let's take a look to see how we do. Run it. Good job, here's your flag, pico CTF debug for the win. And as we can see, we found the flag. You can submit the flag, I already got this during the competition, but that should be it. Alright, so for the second challenge, it is for 300 points. Following the series, WinAntiDbg 0x200. If you have solved WinAntiDbg 0x100, you will discover something new in this one. Debug the executable and find the flag. This challenge executable is a Windows console application. You can start by running with the command prompt. This executable requires admin privileges. You want to start, run as administrator. Alrighty, let's first download and unzip, extract this file. Whoops, pico CTF. Okay, so if we run this in the terminal real quick, I don't think it'll work. Admin privileges. Neato. Let's open as admin. You can see to start, you need to launch this using a debugger. So we need to rerun Binary Ninja with administrative privileges. Let's do that. And let's just open up the file. Alright, so we're going to try to follow our same methodology again as last time. I think again it is the functions are actually obfuscated, so we can't figure out which is main, but we can just start top to bottom. Let me take a quick look to see if we can find any strings here. Interesting. Alright, looks like there's a lot more functionality here. Oh, looks like this might be the main function. Cool. Oh wait, no, this is the text section with all the strings. Okay, we can A little trick that I like to do also is if I go to look for strings and I know it's going to have something like flag. Not like that. Where is it? Or debugger was detected, try to bypass this check the flag. You can find out what function it's actually in and go to that function. So we can do that to cheat. But let's just run this in the debugger real quick. Most likely we'll get what we got last time. Okay, let's run it. And we see, oops, the debugger was detected. Try to bypass check the flag. Level 2, why did the parent process get permission at work? Because they had a forktastic child process. Okay, so most likely they are using fork to create a new child process to detect debugger. Because debuggers don't like that sort of stuff. But I think we can just do it, solve this challenge in the way I did it last time. So let's go back to strings. We can look for any of these strings like challenge. And we can see it is in data A035C1 or C8. We can go look for it here. Type it in. Data A035C8. Okay, well, it doesn't allow us to go through, but we can just manually take a look at this also. That's not a bad idea. Okay, there's a lot of code here. I might have skipped past it. Let me do, what is it? I'm gonna do disassembly mode because I think it's a little bit easier to look at when it comes to these things. We should be looking for that is debugger present again, because there's a chance that they are still using that, and we saw that in the symbols as well. Open process token. Okay, let's just look at this real quick. Alright. It should be a sub function, to be honest. One of these. Alright, we found something interesting here. It's calling is debugger present in this function, and is processor feature present. Let's do a graph view and see. No, that's not what we are looking for though. We are looking for that main function. These are just the different functions they're using in the code. Aha! We have found it. So this is most likely the main function here. To start the challenge, you must run this in debugger. Okay. So if we got that, it'll print the string out level 2, why did the parent, whatever. It said, why did the parent process get promotion at work, blah, blah, blah. And then, so I see what's going on here. It's calling is debugger present, but it's calling other functions before we get to this function. That'll give us the flag if you follow the graph, right? So it's calling sub A011D0, checking it, and then jumping to this address if it's not 0, and this address would be, oops, the debugger was detected. So we want to definitely patch this function. So right off the bat, I'm just going to test it out and invert this by patching this instruction. So now it should jump to this. However, it's also calling is debugger present from last time, so I'll patch this function as well. So in theory, at this point, we should be going down here, and nothing is giving me any alarms. We should be printing the flag out. So let's go ahead and just save that. Let's call it patched. Let's open it and run it. And we should be able to get the flag back from this. Let's run it. And boom. Good job. Here's your flag. Pico CTF. Boom. So yeah, those were pretty easy ways to solve the challenges just by quickly glancing at the code in a disassembler. Just a little quick static analysis there. WinAntiDbg 0x300, this challenge is a bit invasive. It will try to fight your debugger. With that in mind, debug the binary and get the flag. This challenge is a GUI application. Okay, so it's a little different than last time. The last time we had they were console applications. So let's just take a quick look. Extract the file. It does require admin privileges, so we got to keep that in mind. Alright, so let's try to run this real quick and see what it says. Ooh. Pico CTF, welcome. If you have solved the previous two anti-debug challenges, congrats. In the previous two, you were required to launch the program using a debugger to start the challenge. This time, it is a bit different. This program will try to not allow you to launch it using a debugger at all. In fact, this program actively fights your debugger, so don't be surprised if your debugger crashes or exits. This challenge is straightforward. Attach the debugger, get the flag. Good luck. Okay, so we need to attach a debugger and try to get the flag. We do get a PDB file, which means that we will be able to see the function name, so that's going to be useful. Let's pull this up in Binary Ninja first and see what we got to work with. Okay. We can see a lot of these. There's not a lot of functions here. Yeah, there seems to be a lot of missing functionality. Okay, so originally when solving this challenge, I ran into an issue here where I wasn't able to disassemble this binary. And pay close attention to this right here. It says UPX0 and UPX1 sections. If you don't know what UPX is, let me open this up. UPX is an open source executable packer. And so what we really had to do here was unpack this binary. It was actually being compressed and packed with UPX. So we're going to have to unpack this binary before we can even start the static or dynamic analysis. Most likely going to be dynamic analysis on this one, but the way I solved it was static analysis. So let's just exit out of this, discard. And we're going to want to download UPX to save it, but I already downloaded it for the challenge when I was solving it. Over here, I'm going to copy this. Copy. And bring it over here. Alright. So let's open up terminal, run UPX, let's go CMD. Alright, let's decompress UPX tag D and the file, which will be WinAntiDbg. Boom. can see 24,000 bytes. I didn't check what it was before, but let's just trust that it did its job. So let's go ahead and open it with our binary ninja again. And this time we should see a lot more symbols on the side here, as you can see. But remember, we also have that PDB file that they provided with us, so we can actually deobfuscate some of these symbols. So let's try to import debug info and attach this to see what we get. And voila, we see a lot of names. Is debugger present? We see all the names of all the functions, syscalls, all the symbols. So let's take it from the top down. Let's scroll all the way up. If you actually look into the challenge, there are 3 hints. And the first one says there is an infinite loop to constantly check for the debugger. So we know there's going to be some sort of infinite loop. And most likely there are going to be other obstacles along the way. So scrolling down, looking through the function, we can see just initializing GUI functions. Nothing really of interest so far. And there's a decrypt flag function, so it seems like the flag is being encrypted and decrypted. This function, okay, we're getting through the text section. Alright, we're getting through the code. This first function is called winMain. And we see that it is sending out a message box saying oops, debugger detected. Okay, and then it's calling compute hash, which I assume is encoding the flag and stuff like that. So that is very interesting. Let's keep going. We see, okay, pico banner, buff count. We want to find all the instances where the debugger is being detected and inverting these branches. So actually I'm going to go ahead and just patch this right here so that it will bypass this check. Let's continue to look. Loading NTDLL. We want to keep an eye out for that infinite loop. So let's continue. Please run this program as admin, okay. No debugger was present, exiting. Alright, nothing that we need here. Okay, this is the text message for that GUI that we saw when we tried to open up this application in the GUI. So it just seems like it's initializing and stuff. Log to GUI, challenge thread function. So if we take a look here, our process was detected, the debugger was detected. And this is obviously the infinite loop that we're talking about here. You can see while true, which is infinite loop. We switch it to disassembly. This is just jumping in this loop over and over again repeatedly, and it's calling create process. So it's trying to detect the debugger by creating multiple child processes over and over again in this infinite loop. Let's go back to the pseudo-C code. So we need to get out of this and break out of this, obviously. So let's look and see where exactly it's doing this and where we can break out of this code. So it's calling compute hash, so it's also encrypting the flag. We can see it's doing a bunch of stuff here. Debugger was detected, something went wrong with the challenge. Interesting. Let's scroll a little more, see what else we got down here real quick in the subsequent areas. Okay, let's just go back. Doesn't seem like there's anything else that's very interesting down here. So let's go back to that up here. Where was it? So one thing we could do, there's many ways to try to go about breaking out of this infinite loop. You could try to rewrite the assembly instruction to not be a while loop or an infinite loop. Or you can try to find an area where we can exit out of the loop and break out of it and jump to that instruction. So the way I initially solved this challenge was I actually just patched an instruction here. If I switch it to disassembly real quick, we can see one of the jump functions. Where is it? Right here. It's going to jump if equal to 403.8E0. And if you look inside of it, this code, oh, it's not letting me. Okay, but it's jumping to another address that's all the way. Let's look for it. 403.8E0. 403.8E0. It's down. Should be down here somewhere. Right here. It'll jump compute hash. It'll decrypt the flag, and then jump over here to 403.929. You've got the flag. Here's your flag. Okay, so we do want to jump there. At the current moment, it is not jumping there most likely, which is why it will fail if we try to run the debugger right now. And I'll even do that for you guys to show. Launch. You can see we got debugger detected, challenge aborted. So let's go back and patch that instruction. We gotta go all the way back and find it. Where is it? It can get pretty messy up in this assembly. Okay, can't have been too far from here. Alright, I am just lost in the sauce right now. Main about blah 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 blah. I am just missing it, huh? I might be blind. Alright, I'm just gonna do this challenge. It was this function right here. Yep. So where was that instruction that I was looking for? Yeah, it was up here a little bit, wasn't it? This one right here. Okay. So let's invert this and patch it. And let's try to save this and run it now. Launch. And let's see, do we get the flag? Pico, CTF, Windows, AntiDbg, 0200. There's the flag, and we can just copy it from here. So, pretty simple, just breaking out infinite loops. That was the reverse engineering challenges WinAntiDbg. This one was actually the highest rated reverse engineering challenge of the Pico CTF 24 competition. Anyway, YouTube video out. Peace.